So okay, so the function is log 2 x minus 4, and this is the original basically function is already graphed here. And what I did was I graphed the suggested one, which is, as I said, log 2 x minus 4. And the 4 basically, even though it's negative, we can see that um, it it's supposed to basically go to the positive side instead of negative 4. Um, okay, and it's just like moving basically shifting 4 times to the right, and that's basically it for the graph, because we are only adding this negative 4 here to the original function, the y log 2x. So that's why. And the domain, as mentioned, basically is from here 4, and then it keeps on increasing, so it's 4 comma infinity, positive infinity. For the range, we have negative infinity and positive infinity. And for the vertical asymptote, it's here x equals 4. This line, it's basically kind of very close to x equals 4, but it never gets to touch it actually. So that's basically it. So I kind of wrote all this information based on the graph. I didn't basically found the results in details, like from actually I'm substituting numbers to the function and stuff like that, as the problem says. It's only like graph the function and then, you know.
Okay, okay, this is good. The answers are right. But sometimes let's try to use a mathematical language. So two words are here, very important.
Mm-hmm.
One is log 2x. So that's our reference graph.
Mm-hmm. Yeah, that's the.
Right. Then the function log base 2 x minus 4, it's just a transformation of the reference graph.
Yeah, correct.
So that right, because the x minus 4, that's horizontal shift. So it's a shifting to the right 4 units.
Yeah, correct. Only 4 units to the right.
That's right. Great. And the domain is from 4 up to infinity. Great.
Yeah.
Range is from negative infinity up to infinity. Great. Vertical asymptote is x equals to 4. Perfect.
Yeah. From this one, okay, sorry. About this one, the y equals log 2x, the vertical asymptote would be 0, since it would be basically almost touching the 0 on the vertical, the y-intercept, I mean, the y-axis, but it doesn't get to. So, yeah.
X equals to 0. Right? Y-axis has another name. X equals to 0.
Yeah. Okay, thank you.
Great. Okay, that's great. And let's see. You know, anyone's ready, you can share your screen with us.
Professor,
Yeah.
I have a question. I'm trying to show my work, but I'm having technical difficulties. So I was wondering if I can just show it through the textbook and explain how I did it.
Okay, you want to talk
Because
about
I was trying to pull up the email I sent you, but I'm not access to it. My internet is not working right now.
I see. Okay. So
That's okay?
homework 10. But of course.
Okay.
So I was checking to see if anyone wants to show 10. So 10, in which section?
68.
What do you mean 68?
It's a question 68.
Oh, the question 68.
That's homework
Yeah.
10, 4.3.
4.3, 68.
Yeah.
Thank you.
68, yeah.
68. This one, right?
Oh, yes, that one.
My marker. 68. This one. Okay, let's see this one. This one,
Okay.
we need to find the domain of the function. All right, so let's.
Yeah.
So this has two parts. We have a
Yes.
square root of x minus 2, and then we have a log 10 minus x. Well, let's do one by one. Since we have two parts, we need to find the domain for this and domain for this, then take the intersection, right?
Okay.
So
Yes.
what's the domain for?
So for the way that I found the domain for log base 5 of 10 minus x is that I set up 10 minus x greater than 0,
Great. Yes,
and then I solve for x,
right.
and then I got x is less than 10 because I moved the I did the minus operation. So when you do that, the sign changes.
Okay, so this is the domain. Great. This is the domain for log base 5 10 minus x. Now we are going to
Yeah.
consider the domain for square root of x minus 2. What is that?
Yeah.
Yeah.
So the domain, I set the square root of x minus 2 greater or equal to 0.
Right? So just x minus 2 is greater than or equal to 0.
0.
Solve that. What do we
And then I put 2 on both sides to get rid of the 2, and I got x is greater or equal to 2.
Yes. So now we have 2, right? So we need to take an
Yeah.
intersection of those two. Do you see the
Do
intersection?
we need to what?
The intersection.
Mm-hmm.
So basically it's common. Let's use this line. This is real line. So let's say this. So we have two numbers. We have 2, we have 10.
And 10, yes.
So let's move this. Let's say this one is 10 maybe. We call this one 10. And
Okay.
we call this 2. So this point is 2. So the first part says x is less than 10. So going here, right? Down.
Going that way, yes.
We're going this way. And not including 10. So we put an open parenthesis.
Yeah.
Not including because we don't have equal sign. And this one,
No.
this part says x has to be bigger than or equal to 2.
Or equal to 2, yeah.
So that means equal to 2, we make a bracket.
And 2 is included, right, or not?
2 is included because equal
Yeah.
to, right? We make a bracket. Then the arrow goes which way?
That way.
Arrow goes this way.
So right, yeah.
So what is the intersection? We have to find the intersection. So one goes this way, from 10 goes downward, and this goes upward. Do you see this is the intersection?
Yeah, all those numbers.
Yeah, all those numbers. So how do we write? We can write this way. We can write, oh, I could just change this. X is greater than or equal to 2, but less than 10. So let's change it. Let's change it. I don't have enough space. I'm going to write over here. We figure out each. Then, so this is 2 less than or equal to. So this means all the values is in between 2 and 10, including 2, not including 10.
10.
Well,
Okay.
we could use this kind of notation, interval notation. The interval notation, we would write like a bracket 2, 10,
2 and 10.
yeah.
Parentheses.
2,
Okay.
like 10 with open, with closed parentheses. So this means including 10. 2, we write with bracket. Bracket means this includes 2.
2, okay.
Right. Okay, so that's 60. Any other questions? Yes.
All right, thank you, Professor.
Yeah, let's type in the chat. Oh, you're welcome.
Mm.
Okay, so Sarah wants to show 14. Jeremy wants to show 15. Natalie, which one you want to show? Choose a number, all right? Choose a number. Hopefully everyone can show. Oh, 56. Great. I think I put it on. I put everyone because all of you are presenters now.
Ready.
Okay, go ahead. Let me.
You see it?
Yes.
Okay. So 15 is short. It's basically log of 4 to and 16 to the 100th power. It's like the exponent. And so I got 16 to 100, which equal to 4 to 200. And I applied the rule of log a, parentheses, a to the x power equals x. And then I got like 200.
Great.
Yeah.
Yes. Yeah, as Jeremy said, this is simple. We want to use this log base a, then of a raised by x. So we have a log, we have an exponential form, they cancel each other, we just get x back.
Yes.
So here, 16, we can write as 4 squared. So 4 squared, 2 times 100, get 200. So he changed it to be log base 4 of 4 raised by 200. So that's just 200. Great. It's simple, but it's also important. Great. Thank you, Jeremy.
Sure. Thank you.
You're welcome. Okay, Natalie and Sarah. Hopefully, we still have has settled. And we have James, Nikela. Yes, Sarah. Well, when you get, are you ready yet? Samir. Okay, Sarah, go ahead. Share your screen with us. Yes, it's coming up. Okay.
I'm trying to share it. I don't know why it's not showing up.
This maybe you choose the blackboard. If you want to share your screen, choose share application / screen.
Okay.
We're waiting. Okay, yes.
Okay. Can you hear me?
Yes.
So I'm doing homework 11, question 14. So the first step is to rearrange terms. So that way it's going to be log base 3, 100, minus log base 3, 50, close parentheses, minus log base 3, 18. And then you're going to apply a rule, which is log base a, in parentheses, b over c, close parentheses, equals log base a, b, minus log base a, c. So then you get log base 3, in parentheses, 10 over 50 minus log base 3, 18 to equal log base 3, 2 minus log base 3, 18. Again, you apply the same rule. So you get log base 3 in parentheses 1 over 18 equals log base 3 in parentheses 1 over 9 equals log base 3, and then you get 3 to the negative 2 power because you're writing 1 over 9 as 3 to the negative second power. And then you apply a different rule where it's log base a, b to c power, and then equals, and you're rearranging it so it's c times log base a, b, so you get negative 2 log base 3 equals negative 2 times 1, and your result will be negative 2.
Great. Great. That's right. Looks very good. Yeah, and it's very smart to rearrange to do 100 divided by 50. It's easier to get those two numbers. Okay, that's great. Okay, thank you, Sarah.
Thank you.
All right, and Natalie, are you ready? Natalie and
Yeah. Hello.
yes, it's coming up.
Yeah. It's me, Natalie.
Yeah.
Okay. So can you
Yeah, 56, right?
yeah. So this is the graph of I n x, and then it says I n x plus 2, so plus 2, it goes to the left 2 times, so 1,
Natalie,
2.
Natalie, it's
Yes.
not a INX, the LN. LN.
Oh, okay, okay.
It looks like IN.
Okay. Ln(x).
Right.
So this is the graph of Ln(x), and then Ln(x) plus 2 will go to the left 2 times. And then I just drew it through it. And so for the domain, you said to put what is in the parentheses is greater than 0. So it's right here, x plus 2 is greater than 0, x is greater than negative 2. So negative 2 and then infinity. And then the vertical asymptote is right here, x equals negative 2, and the range is all real numbers.
Great. Yeah, that's it. Again, so right, we take LNX as reference graph. So we see LNX plus 2 plus indicates a horizontal shift to the left. Horizontal shift to the left, 2 units. Right, the 1 becomes a negative 1 here. Great. Good job.
All right.
Okay. Good job. And
Thank you.
let me. All right, and let's see. Anybody else? Hassato, I'm sorry, maybe I'm not spell your name right. Hassatou. Do you want to show any work of yours?
Yes, I want it, but I'm not sure. I think I'm gonna upload it and send it to you. I'm gonna present next class.
Oh, okay. All right. But
I
so
just
far you
managed to
did.
understand better.
Okay, I'll see. All right, James.
I'll try next week, Professor. I'm not sure about my answers.
Oh, okay. All right. Well, you can ask me questions. All right.
Mm-hmm.
All right. If something's confusing, you can ask me questions.
Okay, Professor.
All right. You're welcome. Nikayla. Nikayla, can you hear me?
Yes, I can hear you, but I'll present next class.
Oh, okay. But so far, do you have any questions?
No questions.
Okay. All right. Samir is here too. Samir, do you want to show some work today?
Yeah, sure. I'll present homework 9, question 12.
Okay.
Yeah, let me get the file first, and then I'll be ready with you.
Okay. All right. And I remember someone asked me some questions earlier, right? So I answered one question. That's 68. Anybody has any other questions? It's important to remember a reference graph. Then other graphs, we look at it just as transformations of the reference graph. Yeah, so make sure to right, to do homework. So homework to practice those laws of logarithm. Oh, okay. Maybe later on we're going to talk about this. This is good because this is some confusion. The common mistakes. So then afterwards, I'll talk a little bit about exponential equations and logarithm equations, how to solve those two kinds of equations. Okay, Samir, whenever you're ready, you just let me know.
Okay.
Oh, okay, you're ready.
There. So for question 12, we're asked to express the equation in exponential form. So there's two parts. We got A and B. Here I wrote like a little instruction here where we have to convert logarithm form into an exponential form. So for A, we have ln x plus 1 equals 2. You basically just rewrite it as e squared, and yeah, basically move the 2 over, and then you move the x plus 1 to the other side of the equal sign. Then you get e squared equals x plus 1. And then for b, we have line ln x minus 1 equal to 4. We write it this similar to what we did with a, but b we write e to the 4th power. Then we write the whole thing as x minus 1 after the equal sign.
Great, great. I'm really happy about that you're showing those two works.
Thank you.
So logarithm form and exponential form, it's just it's almost the same in disguise, right? We can rewrite log form into exponential form, or write exponential form into log form this way. ln is log base e, so this can be written as e raised by 2 x plus 1. Now, if I ask one more step, I said, okay, solve for x, because I'm leading towards the next material, the next section. The next section, we're going to talk about solve logarithm equations, solve exponential equations. So how to solve logarithm equations? We rewrite as exponential equation, just like this. Right? If I make this solve for x, solve for x. Right? Solve for x. So we just need to do one more step. Right? How do we solve for x in this case? Well, we did minus 1 on both sides, right?
Yeah, we subtract.
Right, we subtract 1 on both sides, so we get x equals to
It equals to 1.
Right, e squared minus 1, right? Because e is a number. E is just like a pi. It's a number. Because it's an irrational, so we just keep it as e. It's called an Euler number. So in this case, x equals to e squared minus 1.
Exactly.
What about b? Jeremy, can you solve B for us? X equals to? We should add 1 on both sides, right? If we add 1 on both sides, so X equals to?
1, well, negative.
1 plus, we add 1 on both sides, right?
Yes.
So then we have X equals to 1 plus e to the 4. Okay, all right, great. Thank you, Jeremy. So let me share my screen. So that's exactly what are we going to do today. So I'm going to solve exponential equations and the log equations. All right. So let's see the first one. So here we have exponential equations. So how do we solve it? We want to write into log equations. So what do? We put the logs on both sides. So we start with 2 raised by x equals 7. Put the logs. Because we have equation, we can do something simultaneously on both sides. So we log 2x, we log 7. You see, we put the ln in front of a 2x, we put the ln in front of a 7. Right? So now, according to the rule of logs, the exponent of 2, which is x, come in front of ln. So that becomes x ln 2 equals to ln 7. ln 7 is a number, ln 2 is a number, and we don't care what it is at this moment. We just keep it. We don't really have to evaluate. But if we want to evaluate, we punch into a calculator, we get ln 7, then we get ln 2, then we divide by those numbers. It's approximately 2.807. All right. So that's how we solve exponential equation. We put the ln in front of both. Then we move the exponent x up front of ln, just like this. So we start with 2 raised by x equals 7. We put ln on both sides. Then we move this x in front of ln. Then we divide by ln 2 on both sides. So x equals to ln 7 divided by ln 2. All right, for us, we don't have to evaluate. But if you are curious, you want to see, what does ln 7 divided by ln 2 look like, you can punch into calculator. So it's about 2.807. All right. Okay. And okay, so this one, so we're in homework 12, right? So I would like to add this into your homework 12. Think about this from A up to J, right? Because true or false, because this will help us to understand the log properties or log rules. So we'll talk about the next class, all right? You can present next class. I'm going to add more about homework 12 later. So I think this is good to think about it, okay? Okay, so let's keep going. Talk about the solve. Okay, let's read these guidelines for solving exponential equations. So this is saying isolate the exponential expression on one side of the equation. Because maybe sometimes we get more terms. Okay, then isolate. So isolate means we only want the exponential term on one side. We put all other terms on the other side. The second one, take the log on both sides, just like this. Take a log, take a ln on both sides. Then bring down the exponent. Right, up front ln. Then solve for the variable x. Let's see more examples. So this question will have 3 raised by x plus 2 equals to 7. Okay, so the exponential term is just by itself. It's already isolated. So what do? We put the ln on both sides. So we put the ln on both sides. So this same, we can put the log on both sides. Log base 10, log base 10, that's okay too. But for your future class, calculus class, we always use ln. So we could use ln on this side, ln on this side. Now we can bring down this exponent, x plus 2 as exponent. We bring down, bring to the up front of ln3. Now we can divide the ln3 on both sides. Right? So we have ln7 divided by ln3 that equals to x plus 2. Then we are solving for x. So we basically move this 2 to the other side, become minus. Or you could think we minus 2 on both sides. So x equals to log 7 or ln7 divided by ln3 minus 2. Okay, by the way, if we have, so log 7 divided by log 3 equals to ln 7 divided by ln 3. All right, as long as they have the same base. This log is base 10. ln is log base e. As long as they have the same base, when you divide them, they're the same. So the ratio of this one and this one are the same. If you have any questions, stop me, all right? So this is saying x equals to this number, negative 0.228. Let's say 3 raised by this number plus 2 is about 7. Let's see this one. So here we have a e raised by 2x equal to 20. So we don't like this 8.
I have a question, Professor.
Yes, go ahead.
You said we didn't need to calculate the log 7 over log 3, right?
Yeah.
Yeah,
go ahead. I'm sorry.
Yeah. You said earlier that we don't need to calculate the okay, for example, the x equals log 7 over log 3 minus 2.
Well, we can
we
leave
stop here?
Yeah, we can stop there. Yes.
Okay.
Yeah. Just if you are curious, you can consult with the calculator to see what the number look like. But this is the estimation. So usually for calculus class, we don't like estimation anymore. We want to keep it exact. This is exact. We can finish up here. Great. That's a good question. Any other questions? All right, great. Right, if you have questions, stop me anytime. So here we have 8. So let's divide 8 on both sides. So once we divide by 8, we have e to the 2x equals to 20 divided by 8. So 20 divided by 8, we can write as 5 over 2 or 2.5. We'll put the ln on both sides. We move 2x down. So we have 2x ln e. Remember, ln e equals to 1. Right? This is one of the properties. So ln e equals to log base e. Right? Log base e of e equals to 1. Whenever the base and the inside the log are the same, that equals to 1. So log e, so ln e equals to 1. So 2x times 1, we have 2x. And this side we have ln 5 over 2 or 2.5. So we divide by 2 on both sides. We have x equals to ln 2.5 divided by 2. Right? We don't need to approximate. All right, that's how we solve. Let's solve more. So let's see this one. We have e raised by 3 minus 2x equals to 4. We just put a log on both sides. Then we move the exponent downward. Again, we have 3 minus 2x times 1. ln e equals to 1. Then we subtract 3 on both sides. We get negative 2x equals to negative 3 plus ln 4. Then we divide by negative 2. So x equals to negative 3 divided by negative 2. That's positive 3 halves. Then ln 4 divided by negative 2. That's just negative ln 4 divided by 2. We can leave as this form if we want. We don't
Professor, I have a question.
Yes.
Did ln eliminate the e?
Oh, yes.
That's why you got.
That's what I wrote here. You see, what's ln e? ln e means log base e of e. That equals to 1. Make sense?
Okay.
Yeah.
Yeah.
Whenever base and the value are the same, so let's say log base a in general equals to 1.
Okay.
Does it make sense?
Yeah.
Because if we write it in an exponential form, how do we write? We write a raised by 1 equals to 8.
Mm-hmm.
Right.
Okay.
Okay. All right. So ln e equals to 1. Okay, let's see this one. This one is a little bit difficult. An exponential equation of quadratic type. So I have e raised by 2x minus e raised by x minus 6 equals 0. So one way we could use a substitution, right? We said, okay, let w equals to e to the x. And then e to the 2x, we can write it as w squared. And e to the x, we write as w. So this equation can be written as w squared minus w minus 6 equals 0. And we know how to solve this. We factor this quadratic form. That becomes w minus 3 times w plus 2 equals 0. Then we can solve this one. So when we solve, we get w minus 3 can be 0. So we can split them. W plus 2 can be 0. And this one gives us two solutions. W equals to 3. W equals to negative 2. Right? Then we substitute back. So W equals to e to the x. Then, so the first one is saying e to the x equals to 3. The second one is saying e to the x equals to negative 2. Well, base e raised by x equals to negative 2 will never happen, right? So this will never be happening. So this does not, the second one, so e raised by x equals to negative 2 has no solution. That means no x satisfies this equation. So we only have to solve for e to the x equals to 3. Right? E to the x equals 3. That's this one. E to the x equals 3. E to the x equals to negative 2 will never happen. So we just reject. This will never happen. E to the x will never be negative value. The least value, all positive values can never be negative, can never be 0.
Why?
So think about this. Let's rewrite this one. Let's rewrite this one. Well, let's think about the x some values, right? Let's give x some values. Let's think about e raised by negative 1. That is 1 over e, right? That is 1 over 2.71a28 right? It's never negative. E raised by a negative number, still a positive number. Or e raised by a positive number, a positive number. E raised by 0 is 1. So e raised by any number will always be positive number. Does it make sense? If we write in log form, right? Let's write in log form. So we write ln e to the x equals to ln -2. Let's see what's wrong with this. Remember, what is the domain of ln? Remember the graph of ln x? Ln x, great. It's about like this, right? The x value has to be positive. Cannot be 0, cannot be negative. But here we have ln -2. -2 is a negative number. So inside ln, inside log can never be negative. That's how we find the domain of ln. So ln -2 is not defined. We don't know what that is. There's no such number ln of a negative number. There's no ln 0, no ln negative number. It has to be ln a positive number. ln, so log follows a positive number, all right? Okay, so that's why this one has no solution. So this one has solution, e raised by x equals 3. Then we can solve, right? We put ln on both sides. We put ln on both sides, ln. So we have this side, we have ln x, ln e to the x. That just become x. ln e to the x equals to ln 3. We move x down in front of ln. So we have x times ln e equals to ln 3. Again, ln e equals to 1. So x times 1 is x. So x equals to ln 3. So x equals to ln 3. That's our solution. You know, ln 3 looks weird, but let's just remember it's an irrational number. It's a number. ln 3 is a number. It's just an irrational number. We just keep like that. But if we're curious about, you know, what is this number, we can punch into a calculator. Calculator will give us an approximation. Any questions? So this one might be a little bit difficult. So you can do this substitution. All right. If you understand, you could do this. So you say e to the, because this is the ex squared, right? Because e to the 2x, we can write as e to the x squared. So this is a square term. Then we can factor this out, e to the x minus 3, e to the x plus 2. If this is confusing, you can use a substitution. You can substitute into a variable. All right, let's see next example. Next example, we have a 3x e to the x plus x squared e to the x equals 0. So we see e to the x both in both terms, right? We can factor it out. Also, we see x is x, both terms has x, so we can factor out x e to the x. So we factor out x and e to the x. Then inside the parentheses, the first term left with 3, the second term left with x. If we multiply out, we still get back this. So we factor out, we have 3 factors. We have x times 3 plus x, and the e to the x will have 3 terms. We can use 0 property, but the e to the x will never be 0. Right? So e to the x will never be 0. So e to the x will never be 0. So that means we can divide by e to the x. So this side we're left with x times 3 plus x. 0 divided by e to the x is still 0. So I have 2 factors. Then 2 factors we can split. We have x equals 0. 3 plus x equals 0. We solve this, so we have 2 solutions. We have x equals 0 and x equals -3. So for this equation, have two solutions. Is it true for x to be 0? Is it true for x to be negative 3? Any questions? So we can check, right? If x equals 0, we check, we see we get a 0 equals 0. So this is 0. If x equals negative 3, we plug in, we also see this equals 0. So it's always good to check. Any questions? Okay. So today we're only going to, well, maybe we'll talk about log 2. Let's see. We keep log next time. Let's do some practice. Let's practice a little bit. Let's try 3 up to 8, right? Try 3 up to 8. Okay. Follow the steps, right? Put the ln on both sides. Move the exponent up front. Then solve for x. Okay, when you're ready, I'd like you to show the work. Okay, should be simple. Don't overthink. It's not difficult. Yeah, whenever you're ready, right? You can explain to us, or you can, if you take picture, you can share your screen with us, or you can use the blackboard. Yeah, Liz is ready. Elizabeth, like to do 3. Okay, we'll give maybe 2 or 3 more minutes.
Okay, so yeah, I'm going to be working on 3. We have 10 to the power of x equals 25. For that, for the first step, we have to take the base 10 on both sides, to then expand the log 10 to the power of x by moving x outside of the logarithm. So we're going to be having x in front of the 10 equals 25.
Not
Then
x in front of a 10, right? You mean x in front of a log 10?
yes.
Yeah. Okay.
Okay. Then we're going to be
Liz, we lost your voice. Elizabeth, we lost your voice.
I think she's having internet issues.
What's going on?
Because I think she's having internet difficulties too.
Like on and off on my side. Yeah, I think she has some signal problems. All right, anyone else wants to show?
Yeah.
Okay, go ahead.
Professor, I started number 4, but I got stuck. I didn't finish it though. I don't know if that's okay, so you can help me out finish it.
Yeah, great. Yeah, let's do it. Yeah, go ahead.
So what my first step was, I wrote ln in front of the 10 and in front of the 4 as well.
Mm-hmm.
And then I bring down the negative x in front of the ln.
Right.
But then I didn't know what to do. Do I divide or?
Well,
That's
let
what
me
I got stuck.
head on this side. So you said, okay, so you bring the negative x up front ln n
Mm-hmm.
and equals to ln 4.
Yeah.
Now, because we want to isolate x, right? So
Yes.
maybe let's divide by -1 first. We'll multiply by -1 because we want to get rid of the negative sign. How can we get rid of
Yes.
the negative sign? Okay. So we multiply by -1, right? Let's multiply by -1 on both sides. So we would get a positive x ln
Positive
n
x.
equals to negative ln 4,
Yeah.
right? Okay,
Mm-hmm.
now we want to isolate x times ln 10. What do you think we should do?
So we divide
We divide. We divide by what?
by -4, negative
Oh,
ln 4.
no, we divide by ln 10, right? Because we have x
Oh, to
times
get rid of it. Oh, okay.
right. We want to divide ln 10 on both sides.
Okay, yeah. To keep
So
the x by on one side.
to isolate
Okay.
So x equals
Yeah.
negative ln 4 divided by ln 10. All right.
That's it?
Yeah, that's it. You say easy, right?
Because I got to that stage, I thought I would have to do something else.
Nope. That's it. Let's
Oh,
keep it. Let's keep it.
okay, that's what I got.
If you want to see this number, what this number look like, you can go to calculator. Calculator will give you approximation for LN4, will give you approximation for LN10. Then you can get
Because because the action said rounded to the 4 decimal places.
right, they will round it to a decimal number. But for us, we don't need to. Okay, just leave this
Oh,
as answer. This is the
okay.
exact, right? LN4
Okay,
next
got
to
it.
LN4 divided by LN10, exact answer.
Okay,
Okay,
got it.
okay,
All right,
great.
thank you. Mhm.
Rina wants to show 5. Great. 5. Rina, you want to share your screen or you want to talk about it?
I'm sharing it.
Okay. Okay. Kelly, you want this to 6. Good.
So, for 5, I put ln on both sides, and then since ln e turns into 1, so it's just negative 2x. Oh, and then I took the exponent down to the outside, so negative 2x, because the 1 is going to be the same. So then ln 7, and then had to divide by negative 2 on both sides, so x equals ln 7 over negative 2.
Right. Exactly. But usually we put this negative sign up front. We say x equals to negative ln 7 divided by 2.
Oh,
Yeah. Great. Good job. Good job. All right. Natalie, 6. You see?
Can you please pull up the textbook?
Okay. A lot of times we overthink, so then we made the question, more difficult than it has to be. Actually, you see, it's easy, right? It's not difficult. Okay. 6, right?
Yeah, 6. So ln e to the power 3x equals ln 12. And
Right.
then
Basically, you're saying this is 6. Let me make here. So we take out n on both sides.
mhm.
Go ahead.
And then since ln e is 1, you bring 3x in front. So 3x equals ln 12.
Right.
And then you divide by 3.
Okay. X equals to.
ln 12 over 3.
That's it. That's it. Perfect. That's it. Okay. Anybody else? Thank you.
Okay, so my internet crashed earlier when I was in the middle of explaining.
Yeah, we did good.
Okay, so I will do it again. So I'm working on number 3. That's 10 raised to the x equals 25. So we take the base 10 of both sides, and then expand log 10 to the power of x by moving the x outside of the logarithm. So basically x log 10 equals, log equals 25.
Okay. Yeah.
Then we know that the base 10 of 10 is equal to 1. So we just basically put x multiply 1 equals log of 25. That's the next
smart.
step.
Instead of use ln, use log base 10. Right.
Yes. And then we just multiply x by 1. And that would basically just give us x equals log of 25. But if we want to solve it, that would be x equals 1.3979 if we rounded it to the 4th decimal places.
I see. You could do that, or just leave as x equals to log 25. That's perfect.
Yeah. Okay.
Okay. Great. Great. Okay. See this way. Yeah, it's smart to use log base 10 because we know log base 10 equals to 1. In this case, we'll get x equals to log base 10. We don't have to write the base 25. Great. Good job. All right. Anybody else? Really good. Okay, see, it's not difficult to get presentation, right? Grades. Okay, anyone wants to try number 8, number 7? Let's try number 8 and number 7 together. Oops. So number 8. Let's try number 7 first. So this is 3. Number 7, let's put ln on both sides. We would have ln 2 raised by 1 minus x equals to ln 3. Then we move down the exponent. So we have 1 minus x. Now the exponent has 2 terms. So we put parentheses around. We have ln 2 equals to ln 3. Then let's divide by ln 2 on both sides. So we have 1 minus x equals to ln 3 divided by ln 2. Right? So first step, we put ln on both sides. The second step, we'll move down the exponent. The exponent has 2 terms, so we'll put the parentheses around. Then we divide by ln 2 on both sides. So we have 1 minus x equals to ln 3 divided by ln 2. It's a weird number, so who cares? Let's just keep it. Then we minus 1 on both sides. So negative x equals to ln 3 divided by ln 2 minus 1. Right? We subtract 1 on both sides. Then we divide by negative 1. Or we multiply by negative 1. Multiply by negative 1 on both sides. We get x equals to, well, negative 1 times negative 1 becomes positive 1. And this ln 3 divided by ln 2 becomes a negative. So we would write this as 1 minus ln 3 divided by ln 2. Right, so x equals to 1 minus ln 3 divided by ln 2. We just keep this answer because this is the exact answer. We don't have to estimate. We don't have to give an approximation. Okay. Any questions?
Yeah, I have a question.
Yeah.
So like for you have x equals 1 minus ln 3 over ln 2.
Mm-hmm.
That bad if I ended up having x equals negative ln 3 over ln 2. Like the 1, I don't have the 1.
Oh, why you do not have 1? You see the third step, we have 1 minus x. Because the exponent is 1 minus x.
Then if you divide by 1 on both sides, wouldn't ln 3 and ln 2 stay the same?
By ln 2, ln 3, what do you mean?
Like you multiplied by 1, but I divided by 1 on both sides to get rid of the 1.
Oh, that's a good question. Can we divide by 1? We don't have 1 times negative x. We have 1 minus.
Oh, you're right. I forgot.
Right. So we need to subtract x on both sides. Yeah. Okay,
Thank
good. You're welcome. Good question. Okay, anybody has question over 7? All right, good. I'm going to leave you homework. All right, let me write down the homework. So homework. Remember, I want you to do this part, right? 72 for 4.4. So let me write here. So homework number 12. section. I was just talking about it. Now I forgot. 4.4, right? Right, 4.472. 4.472. Very important just to figure out which one is right, which one is wrong. You know, why they're right, why they're wrong. Then 4.5, I'm going to choose 4.5. We'll talk about, we only finished half of it, solve exponential equations. So I'm going to leave your work for only for solving exponential equations. Next time we're going to talk about solve logarithm equations. So let's try 12 up to 24 with the even numbers. All right. 45, 12 to 24 even numbers. Even ones. Even. Then try. Actually, let me just add one for challenge 26. Okay, let me add the 26 also. Yeah, add 26. Then let's do 2 from this. So let's do 30 and 32. Oh, also 30, let's see. 30, 32, 34. Let's do these three. 30, 32, 34. So 30, 32, 34. All right. It's homework. So I'm going to post this homework on Blackboard also. All right. Anyone has any questions? If not, have a good weekend. I'll see you next week. All right. If you have questions or anything else, send me an email.
Oh, Professor, you said we could stay and ask to tell us our grades after the class.
Yeah, if you're considering that, I'll tell you.
Okay.
Let's do Natalie.
Yeah.
Natalie. You're fine, Natalie. You're doing fine. Just maybe do more presentation.
Oh, I present almost every time. And I'll be like solving the classworks.
Just today, right?
Yeah,
so
like
sometimes, right? Yeah, try to do more. Try to do more. Yeah, you're pretty good. Pretty good.
oh,
Yeah, your homework is very right. Update. Pretty good. Very good. Anybody
okay.
else?
All right, bye.
Bye. See you next week.
Professor, I have a question.
Yeah.
Do you mind? I asked this earlier, but I guess you forgot. I got stuck on homework 10, question 75 to 78. If you could do one of those, the session is 4.3.
Sure. Homework. Homework 4.3. Let me go to 4.3.
Yeah.
4.5. 4. 4.3. Which number?
75.
75. Okay. Let's see
Yeah.
75. Can you see my screen?
Yes.
Okay. 75, we have f of x equals to 2 raised by x. G of x equals to x plus 1. We want to find f composed with g and g composed with f.
I was able to set it up, but I didn't know how to find the domain anymore.
Oh, okay.
I got confused.
Let's talk about the f of g, right? So f of g equals to 3 raised by x squared plus 1, right? 3 raised by x squared plus 1. You see this?
Yes.
F composed with g. Okay. So this is exponential function, isn't it? 3 raised by something.
Yeah.
So do you remember the graph for exponential function?
Yes, it's like a curve.
Yeah, like a curve.
Yeah.
You see x goes on to the negative infinity up to positive infinity because remember
Positive
it goes
infinity.
on forever.
Yeah.
So all real numbers is a domain.
Okay.
Right, when you do g of f, let's try g of f to see what we get. So g of f. That means g takes f as input. So what's f? 2 raised by
F is 2 raised by x.
right. Now what does g do? G says add 1 to the input, right? So add 1
Yes.
to the input. So 2 raised by x plus 1. Again, what kind of function is 2 raised by x plus 1?
Exponential as well.
Exponential as well. What is the domain?
Yeah.
All
All
real.
real numbers.
Great. Great.
Okay.
That's it.
All right. Okay, I got it now.
Okay. Any other questions?
Now, and how am I doing your class?
So this, let me see. Oh, Tijeta, right? Tijeta, I think
Yes,
it's fine. Tijeta. Yeah, I received all your homework. Your presentation
Okay.
well. Yeah, try to do more of the presentation. Great. I think you're doing great. You, Natalie,
Okay.
great. All right.
Okay.
Okay. Happy
Thank you,
weekend.
Professor.
You're
You
welcome.
too. Thank you.
Okay, bye.